Hey, are you paying 9K to fry your brain? Welcome to You Gotta Be Kidding Me, episode 1, which is an introduction to the nephron. This is a series of shortish, hopefully concise videos explaining the harder parts of kidney physiology, and my aim is to go through each of the parts of the kidney, kind of dissecting it and tell you all the processes that happen there. So we'll start off with the big picture view, which is kind of what I like to do, and we'll just give you an introduction to the kidney. Again, this might be quite basic, but just so we're on the same page. Okay, so we start off with the heart, always a good organ to start off with, and this is going to be pumping blood around the body and to the kidney. So the way it pumps blood to the kidney is through an arterial network, and this network is called the afferent capillaries, or the afferent arterials. So the afferent arterials are the ones that are carrying blood away from the heart and towards the kidney. Okay, this afferent arterial is going to continue onwards until it gets to like a meshwork kind of bit, like where the capillaries go, they will coil up into something called the glomerulus. And what that does is the glomerulus basically acts as a sieve. So essentially, the high pressure of the afferent arterial can force out the liquid water and solutes such as glucose and ions as well, for example. But importantly, your proteins such as hemoglobin within your blood, for example, your red blood cells, albumin, for example, they're not going to be able to pass through. Okay, and the glomerulus is surrounded by something called the Bowman's capsule. I'm telling you this because I always used to get confused between like which one is which. So the Bowman's capsule, yellow in this diagram means it's like from the nephron, it's the kidney, and red is obviously arterial. So if continuing with the sieve analogy, if the glomerulus is like a sieve where it sieves out stuff, the Bowman's capsule is like the sink pouring stuff down the drain. So this is basically the stuff that takes all the goodness from the arteries and does stuff with it, basically, and filters it. Okay, then our blood continues after going up through the glomerulus, it continues and then it exits. So it's kind of done its work in the cortex and it exits via an arterial called the Efferent Arterial. How do I remember Efferent? Sometimes you can get confused between them. So obviously, if you know your alphabet, A comes before E, therefore Afferent comes before Efferent. Okay, hopefully that's simple enough. Let's get rid of the circulation stuff because it gets in the way. Before I move on, there's two parts to the nephron which you should know about. So this kind of nice bit here, afferent, efferent, glomerulus, Bowman's capsule, this is all in something called, oh, this is all in something here called the cortex. And underneath our cortex, so kind of lower, we have our medulla. Okay, so what's this part of in our brief tour, what's this part of the nephron? This is the proximal convoluted tubule, and the convoluted tubules are in the cortex, so convoluted cortex. And the end part of the proximal convoluted tubule is more of a straight bit. So convoluted basically just means wavy. So at the end part, we have something called the straight tubule, which is also proximal. Proximal means near, so like kind of the first one. So this is your first tubule. It's the proximal, this is the convoluted bit, and then you have a straight bit as well. So they're abbreviated to PCT and PST. Then the proximal straight tubule continues downwards, and it forms the loop of Henle, which I'm sure you know about. This is where like the majority of the juice kind of happens, the goodness. This bit here is thinner than the other bit and is descending, so it's called the thin descending loop of Henle, and that can be abbreviated to LOH, loop of Henle. And if that's thin and descending, then the other one must be opposite, so it's thick and ascending. And it's abbreviated to TALH. Okay, the thick ascending loop of Henle continues on to something called the distal convoluted tubule. Remember I said it's convoluted, so it's in the cortex. And convoluted means wavy again. And the DCT continues on to two things, which are again pretty much similar. The cortical collecting tubule, so cortical because it's in the cortex, and the collecting duct, which is in the medulla. And by the time we've reached the end of the collecting duct over here, we've basically formed urine. Okay, there's a couple of things to add. One is your efferent arterioles. They don't go straight back to the heart. They actually form a network of capillaries called the peritubular capillaries. And I've just kind of missed out the blood supply here because it gets messy. But imagine these go round and they form the peritubular capillaries. This white bit here is called the interstitial space. Okay, the peritubular capillaries, they basically have a higher osmolality because all the water basically from not all, but a lot of the water from the afferent arterial has come into the bone's capsule, has kind of been forced into here. So therefore there's less water here, more solutes, you get a high concentration of stuff. So these are better suited to reabsorption. Okay. You also have specialized cells that I'm going to touch on very briefly. Again, we'll go into more detail in the future. But you have specialized cells on the distal convoluted tubule. So if you see here the afferent arterial, which is where it all starts, where it all began, the afferent arterial is very, very close to this side of the distal convoluted tubule. So because of that, the distal convoluted tubule has these specialized cells called the macular denser cells, MD cells. And on this side of the afferent arterial, you have cells called the juxtaglomerular apparatus, JGA. And essentially the purpose of the juxtaglomerular apparatus and the MD cells, which are on the distal convoluted tubule, is they can communicate with each other through tubular glomerular feedback, which I'll talk about later on. Okay, so what is the job of the MD cells? They basically sense sodium. So any filtrate that is made its way to the distal convoluted tubule will have sodium in it still, although a lot of it will be reabsorbed but in the PCT, but there will be some still in the DCT. So the MD cells sense how much sodium is there, and they kind of have a clever idea. They're like, the more sodium there is, then the more kidney is doing work, because basically their idea is that sodium levels are proportional to GFR. GFR is obviously the filtration rate. So if sodium increases too much, they're like, okay, the GFR has increased quite a lot as well, which means that the kidney is probably doing a lot of work, which means it might be damaged. So if the GFR is too high, because the pressure of the stuff going through the nephron is too large. So these guys are like, if they sense too much sodium, they're like, okay, we'll tell the JGA to reduce the GFR, and they signal this via adenosine. This is called tubular glomerular feedback, but that's just to kind of orientate you where you're looking at. And as I said, the peritubular capillaries, they have a higher oncotic pressure. They allow for reabsorption.